Hello, algebra students. We are finally wrapping up our unit on radicals. Our next class is going to be the test. So today we are reviewing all of the stuff with radicals, not necessarily in the same order that we learned it in, but let's go through this. The problems that I have on here, this is the entire review worksheet. I'm not going to do every single problem. The answer key is in Schoology. You can check all of the problems if you get stuck on any of them. I'm going to pick a couple on each slide so that we make sure that we get a good mix of all the different stuff that you could do here. So these 6 problems are from our most recent topic, which was adding and subtracting radicals, which means we have to first simplify each of the parts and then see which ones are like terms, which things would match and could go together. So I'm going to take a look at number 3. First of all, the negative 2 rad 3 doesn't have to change. The 18, I could split that into a 9 and a 2. That gives me my pair of 3s. The 8, I can get those 2s, and I've got a pair of 2s with a leftover 2. So what I have right now is negative 2 rad 3 minus the 3 from here, and then the 3 that broke out, rad 2, and then minus, from this minus right here, that's subtraction, the 2 that broke out, and the rad 2. Now, I know I'm going to kind of write over the number 5 problem in mine because my marker is kind of big compared to what you guys would be writing with. But you can also see that these 2 are going to be the ones that match. The first one won't match. That's just going to stay, just cross that out, as the negative 2 rad 3. This middle term is going to be minus 9 rad 2. Now you've got a minus 2 rad 2. Feel free to change those for the keep, change, change if that helps you. So I would have negative 2 rad 3, and then a negative 9 rad 2, and a negative 2 rad 2 would be a negative 11 rad 2. Let's also, let's see here. Let's do number 6. None of those radicals right now seem to match. When I split up the 24, I would use a 4 and a 6, or an 8 and a 3. I'll have a pair of 2s. And then remember that 6 doesn't give me any other pairs, right? I didn't do this in the last problem, but you can certainly do that if that helps you to keep these straight. 3 rad 6, that's not going to change. The 54, though, could be a 9 and a 6. There's a pair of 3s. So I had the 2 that was on the outside times the 2 that broke out, left over 6. 3 rad 6 was our middle part, and then negative or minus 2 times the 3 that breaks out, 6 left over. So these are all going to be rad 6s. So I'll have 4 rad 6 plus 3 rad 6 minus 6 rad 6. We had a problem very similar to this in the last lesson. 4 of those rad 6s plus 3 of those rad 6s is 7, minus 6 of those rad 6s is just going to be 1 rad 6, or just rad 6. This was just the multiplying part. Number 7 is actually really, really easy, but I think a lot of people are going to make this way harder than it needs to be. Number 7, I'm going to tell you right now, the answer is just 40. You have a pair of 40s. They're both in radicals. They match. You could just circle them exactly the way they are. If you wanted to split each of them up, you could do that. Or you could put them both together to get rad 1600. 40 times 40 is 1600. And then I would do, oh yeah, that's 40 times 40, by the way, which is what I started with. And then I'd say, oh, there's pair. It's just equal to 40. There's no radical leftovers. You could certainly split up the 40s into 8s and 5s and get all your 2s and get your pairs. It'll work. 40 is just a lot faster to write it that way. On a problem like number 9, I've made comments about numbers like 42 and 30, and some people are like, oh, they're so big, they've got to split up, they've got to break down. And neither one of them do on their own. I would also say you don't have to multiply the 42 times the 30 to make one gigantic radical. I could just split each of these up. Say 42 is going to be, oh, that's 7 times 6. I know that the 6 is going to split up. I'm going to show you a trick in a second. The 30, I would say that that's 6 times a 5. Now, if you really wanted to, you could split up your 6s to be a 2 and a 3 and a 2 and a 3. You get a pair of 2s and a pair of 3s. Or you could just say, oh, there's a pair. They match. That breaks out. The 7 and the 5 go back together. Okay? And I'm going to do number 11. Again, I would not necessarily multiply the 18 and the 12. I know this is really a -1 in front of this. You certainly could, but you can also just split each of them up to get some pairs. There's a pair of 2s, both under different radicals, but they are under radicals. The 6 would be a 2 and a 3, but I don't have another 2 or another 3 to go together with those. So I had the 8 on the outside. I had the -1 also on the outside. I broke out a 3, I broke out a 2, and I'm left over with a 6. So I know that's going to be negative. 3 times 2 is 6, times 8 is going to be negative 48, add 6. That was our normal multiplying. We also have distribution problems. Sometimes we're going to have radicals, and in fact, on all of these, we've got radicals that are distributing. So if I would distribute this rad 30, remember the 4 is not in a radical. We're not going to put this together and make a 120 in a radical. The 4 stays on the outside. The 30 stays on the inside. That 7 is on the outside. It stays on the outside. In fact, I'm going to write it as 7 rad 18 and then also rad 30. Because again, you could multiply the 18 and the 30 and get 540, but then you got to break down 540. I could just keep those as separate radicals and make a tree. Notice I picked 3 and 6 instead of 9 and 2, because here I can get a pair of 6s. The 3 and the 5, those don't break down. The 30, we've looked at that. You even have a 30 here, a 6 and a 5. I would have 2 times 3 times 5. Nothing pairs up in that 30. So I have 4 rad 30, and then I had the 7 on the outside. I'm going to break a 6 out, and the 3 and the 5 go back together. The last thing I have to do is just multiply the 7 and the 6 together. And again, the 30 and the 15, they don't match. There's nothing there that's going to be able to go together. This isn't like the adding stuff that we were just doing. Let's also do number 16, just because 15 kind of runs into that. Actually, 15 is probably more difficult with that 42. So I guess we could do that one instead. I, again, would not multiply the -42 times the negative rad 42 times the rad 14. I would just smush them right next to each other. Then the negative, remember that's really a -1 that's right there. When I distribute over here, I'll have -1 times 8 is going to be -8, rad 42. Now, we've looked at 42. That's a 6 and a 7, 2 and a 3. There's no pairs in 42 all by itself. So that 8 rad 42, that's just going to stay. However, this 14, I can do this. And don't forget about this. So I had that negative that was on the outside. I broke out a pair of 2s and I broke out a pair of 7s. The leftover from this part is just that 3. So I would combine the -2 and the 7, multiply that to get a -14, rad 3 minus 8, rad 42. some of the radical division that we've worked with. Some of these are nice, easy radicals to work with. For instance, in number 17, that rad 9 in the bottom, I hope that you're okay with just saying the square root of 9 is just a 3, not rad 3, just 3. 14 doesn't have any pairs. It's just a 4 and a 2 and a 7. Done. Nothing else to do there. In number 18, you have two options. You could simplify the rad 54 and change that rad 9 into just a regular 3. Or I could look at the two things with the radicals and say, oh, I could divide them both by 9. That would make this into a 6, still in the radical, and that would be a 1. So on the top, I would have rad 6. On the bottom, I have 3 times rad 1 is just 1, so 3. Now remember, the 3 is not in a radical, the 6 is. You cannot simplify that any more than that. In a problem like number 20, actually let's just do 19 also. The 2 and the 98, neither one of those are perfect squares. So I would just divide them both by 2. This will be a 1, this will be a 49. So what I have right now, just rewriting it, is rad 1 over rad 49, which would be square root of 1 is 1, square root of 49 is 7, 1 7, done. 20, I wouldn't bother simplifying the 16 and the 20 right now because 16 is a perfect square. If and you can, there's other ways to do this problem, but I would start by looking at that denominator and saying that's just going to be 8 times the square root of 16 is just 4. Again, not rad 4, it's just 4. Rad 20, I can have a pair of 2s, and I've got that 5, so it's going to be a 2 rad 5. You could multiply and get a 32 in the denominator and then simplify, or I could say, let's divide that by 2, let's divide that by 2. I'm going to get rad 5, 4 times 4 is 16. On these last couple of problems, it's very similar to those last ones. We just did more of the division because there's just more to worry about with division. Some of these are nice, perfect squares. Some of them are not. So for 21, for instance, the 21 and the 300, I could divide both of those by 3. If I do, this will be a 7, this will be 100. So I really have 6 rad 7 over 5 rad 100. 6 rad 7 is just done. But 5 times the square root of 100 is 10. Okay. Since there isn't really anything else new on this slide, I'm going to say if you get stuck on anything, check the answer key. Let me know if you need more help, but these are just more of the radical division. Today's worksheet, reviewing all operations, the answer keys in Schoology, and then make sure that you take the formative when you're all done. Let me know if you need any help. The test will be coming up next.